Previously, we discussed gravitational potential energy. There's also another type of potential energy, that is elastic potential energy, denoted as U sub E. Now, just as in the previous examples, if you will take the time to pause the video after I ask a question or ask for a calculation and attempt to do it yourself, you'll gain much more out of this exercise. So we have here a force applied, an external force. The system is the block and the spring. So a force comes from outside the system and compresses the block and spring from the initial position xi to the final position xf. And I show on here the positive x direction and the positive y direction. What is the spring force? Well, do you remember what Hooke's law is? The spring force, or the force the spring exerts on the block as it's being compressed, is simply going to be proportional to K, or proportional to the displacement x in the I minus I hat direction. What is the applied force in compressing the spring? Well, that's simply going to be the opposite direction, a force applied in the opposite direction. And that's simply going to be Kx I hat. What is the differential displacement dr? Once again, the differential is dx because that's the direction we're moving in. And the unit vector associated with it is I hat. So dr vector is equal to dx I hat. What is the definition of work? By now this should be second nature. And is simply the integral from xi to xf at the applied force and the scalar product of the differential, dr vector. Calculate the work done in compressing the spring. In this case, we cannot pull the applied force from outside the integral since it is a function of x. And so we have to write it as a function of x. So it's going to be the integral of xi to xf, kxi hat, dotted into dxi hat. We can pull the k out because the k is the spring constant and integrate x prime dxi dot hat. Carrying out the integration, we find out that the external work is equal to 1/2 k, the x final squared minus x initial squared. And if we assign xi as equal to 0 and x final as equal to x, we can write it as the external work is equal to 1/2 kx squared, where this x squared is equal to the displacement from the equilibrium position. We call this the equilibrium. All right. Notice that whether I displace it positively or stretch it in the negative direction, it is still a positive work being done, x squared. We identify elastic potential energy, UE, as equal to 1/2 kx squared, where x is the displacement from equilibrium. Okay, we talked about what x is. End of discussion. Key point, UE, and now we also have UG. So we have both those.